Hi everyone, this will hopefully be a fairly quick recording of a travelling salesman question from a 2024 paper. And what I like about it is it does the minimum spanning tree ×2, which has never occurred on any papers before. So it's well worth looking at. Right, so let's have a quick look down here then. So it says, use Prim's algorithm starting at D to find the minimum spanning tree. You must clearly state the order in which you select the arc. So you can't just have the numbers across the top. That doesn't get it. Don't get your full marks. You need to write down the edge as well as you go. Right. So I've got it on the next page for starting. So look. Okay. So where am I starting from? So does it tell me in that question? Starting from D. Right then. So as neat as I can, which is a pretty rubbish on here, I'm going to delete D, number D, circle the smallest in D, which is 24. And then what I'm going to do, I'm going to write down ED, 24, but also I'm going to draw it in down here. So it's done there. Then start at E, so I'm going to delete E, number E, and then look down D and E to look for the smallest, which will be that, 26. So I'm going to write D for 26, oops, and then add it to here. So if I continue that, I'm just going to cheat a little bit. I'm just going to so delete number circle. For speed, what I might just do now, so you'd continue that process until you finished. If I just stick in the circles like they're supposed to do, you want to do this clearly. You're doing the proper algorithm all the way through. I've did for the first three, so you should hopefully know the numbers across the top. Like I said, you don't get full marks if it's just the numbers across the top. You need to have all the edges. See if I can copy down without making any mistakes. I'm sure that won't be the case, but there we go. And in terms of drawing, look like that. So that was the first part of it done. So use Prim's, start do. So state the weight, yeah, do that, 243. Draw the minimum spanning tree, yeah, do that. So let's have a look. So it says a historian needs to visit all the castles, starting and finishing the same castle, and wishes to minimise the total distance. Use your answer to part B, so I've got to use the one I've got up there, to calculate an initial upper bound for the length of the story. So this is the MST ×2. It's the only time it's appeared. So for part D, I'll put it on the next page. Under this. There was 2, I'll put that MST ×2 is 241 ×2, 482. Going back to the question, so I've done that. So E part 1 says, use nearest neighbour to get another upper bound starting at D. So there is no kind of like real way to show you how to do it. But I always take this as a from, this is a 2. So if I'm starting from D, my closest one from D is going to be to E. So I've got D to E. I can write it down here. E's 24. So then I go to E, and I think, like, where's the shortest I've not been to? So that would be to H for 30. The D, E to H for 30. Then I go along H and I say, where's the closest that I've not been to? So that would be to J for 33. And I keep on repeating that method until I get back to where I started from. From C to B to G to F to A to D. And there we go, I've gone back to where I started from. But I have the numbers on. So you just kind of like keep going, taking your time, just rushing this bit. Just so you can get to the important parts. So that's 318. So now let's go back to the question again. So I've done that part. It now says write down which route gives the best upper bound. So I've got a choice here now. That's in part 1, part 2. I've got a choice. I've got MST times 2, which was 482. I've got nearest neighbour from D, which was 318. And the question also said on part E, part 2. Oh no, that's it. It's the other one. I've just got extra choice. So it's just them two. And the best upper bound is the smallest, because you want to close down the gap in between the numbers. So I'm going to use the 318. Yeah. I did mention 352. I knew it did. I knew there was mentioned something earlier here about it. There's a random 352 here somewhere. I'm sure. Okay. Oh no, I've done that, sorry, that's part 2. It's F, there we go. Stating the best. 352, the nearest neighbour from F. From there, like, nearest neighbour from F, 352. So your best ones are small, so we use 382, which is the nearest neighbour coming from F. So that was part 2 up there as well, so that's F. Okay. So F there for the choice. So next, what's my G? Oh, I'm missing a page off this. So G asks you to delete a vertex at A. So part G asks you to delete the vertex at A to look for a lower bound. So if you're deleting a vertex, you look for your 2 smallest from A. Turn over the page so that's the right way around. So that would be AD for 26 and AF for 40. So that there is 66. And then I do what we call the RMST. So it's a minimum spanning tree of what's left. So if I get rid of A completely, I'm going to look for the residual minimum spanning tree. And I'm just going to like zip through it using prints, because that's the easiest. It doesn't matter where I start from, but if I start from B, at least I'm kind of looking in the right way. You can do it by just observing what you've got left. But you should get, using prints now, you should get CB for 28, DC for 33. Oh, nice. Good work. I did work with mine. DC, ED for 24. HE for 30. JE for 31. GH for 34. FC for 35. So just continued with prims, doing it properly. And that gave you 215. So if someone deletes a vertex from A, was 215 plus 66, which is 281. There. Right, so the next part of the question, which I managed to delete off. So for H, it told you that delete a vertex from J was 274, and you had to state the best lower bound. So I've got a choice. Got delete a vertex from J, which is 274, and delete a vertex from A, which is 281. So remember, the idea is you've got all these uppers, you've got all this time, and you've got all the lowers. You don't want this massive time gap between the smallest lower and the biggest upper. You want this little gap here. So I want the smallest upper and the biggest lower. So I'm going to go with, so I'm going to use 281, like delete vertex from A as it's bigger. There we go. Did I kind of make it clear that I was using the smallest on the other one? Yeah, that's what I'm smallest. There you go. So I quite like that question because it does do a bit of everything. Got some prims knocking about. It's got some minimum spanning tree times 2, some nearest neighbour, and some delete a vertex. Right, so we'll stop. Cheers.